Okay. So last time we wrapped up with our features created, including SMA, EMA, RSI, MACD, Bollinger Bands, and ATR. We also pasted in the code for defining and training the model using XGBoost, which we got from Gemini. Now, let's take a closer look at what's inside that part of the code. First, let's check what Gemini tells us about the key changes it made to the code, and what considerations we should keep in mind. So basically, Gemini made the code more robust by adding checks for missing data, improving how features are selected, and simplifying the XGBoost setup for newer versions. It also clarified the target definition, added error handling and print statements for better feedback, and gave options for upgrading to a more advanced multi-class trading model later on. That's cool, thanks Gemini. Okay, so here we start by preparing the data, creating a target based on future price movement, selecting relevant features, and splitting it into training and test sets in time order. Then, we train an XGBoost classifier to predict price direction and evaluate its performance using accuracy, classification metrics, and feature importance. So let's see if it's going to work. And unfortunately not completely. So as usual, let's copy the outcome, paste it into Gemini, and follow its instructions on what to do next. So Gemini is telling us that the symboled column is causing issues because it's a string, and XGBoost only works with numeric data. To fix this, we just add symbol to the calls to exclude list in our prepared data for model function so it gets removed before training. The rest of the code should stay the same. So let's fix it and add all the info Gemini gave us about the problem and the solution. And now that we've fixed the code, let's run it and see if everything works. And it works. It's amazing how simple coding can be these days. Don't you agree? Alright, so as you can see, the model was trained using 17 technical indicators, and we can see 10 of the most important. Also, while the overall accuracy is around 51.5%, we can see it struggling a bit with class balance, especially on the positive class, but indicators like Bollinger Bands, SMAs, and MACD are showing up as the most important features. Cool. So let's save the notebook. Now, if we're unsure about what these results mean, we can always just copy and paste the output into Gemini and ask it to explain everything for us. And as you can see, Gemini gave us a pretty comprehensive answer regarding this output. It confirmed that the model trained successfully after fixing the symbol column issue and explained that we have over 4,400 training samples with 17 features, mostly technical indicators like SMA, MACD, and Bollinger Bands. The model's accuracy is about 51.5%, which is just a bit better than random guessing, common for a first try in noisy financial data, and it's better at predicting when prices won't go up than when they will. Gemini also highlighted the top features influencing predictions and gave practical next steps, like refining our target, improving features, tuning hyperparameters, and eventually backtesting to see how this performs in real trading. So overall, we have a solid working pipeline and a baseline model, and now let me paste it to our notebook, so you can read all of that if you want later. So, now that we've completed the machine learning part of the bot, let's move on to the next steps Gemini suggested earlier. This time, we'll try backtesting the model to see how well, or poorly, it would have performed on historical data. Gemini already gave us some code for backtesting, but we'll need to update it to fit the changes we made to the bot. Finally, we'll put everything together in our notebook and run the full workflow. So, as you can see, Gemini tells us to install Matplotlib and provides the code to run. Like before, it also explains the key changes and considerations, which you'll be able to read in the notebook. Basically, Gemini gave us an updated backtesting function that aligns model predictions with test data, applies realistic transaction costs on both buys and sells, logs each trade, and plots portfolio value over time for easy analysis. This simple, vectorized backtest assumes a fixed trade size and no slippage, providing a quick way to evaluate the model's potential before moving on to more advanced backtesting tools. So, let's install Matplotlib. And I already have it. Good. So let's continue with the rest of the code. So, as you can see, this function runs a simple backtest using the model's predicted signals to decide when to buy or sell. It assumes we trade a fixed amount each time and includes realistic fees on both buying and selling. The code keeps track of how much capital and BTC we have, logs every trade we make, and calculates the portfolio value step by step. Then, it plots the portfolio value over time, showing markers where actual buys and sells happened, which makes it easy to follow what's going on. Before running the backtest, it lines up the model's predictions with the test data prices to make sure everything matches up correctly. There's also some error checking to catch issues like missing data or feature mismatches. Overall, it's a quick and handy way to see how well our model signals would have worked in the past before diving into more complicated backtesting tools. So, do you think this code will run smoothly? Or do you expect any issues? We'll see the results in the next part of this tutorial, but if you want, you can of course download the code from my site and try it out yourself. Have fun. And that's it for now from me. I hope you enjoyed this part and learned something new. For now, I wish you all the best. And remember, improve yourself, improve your business, improve the world, but also live and have fun. Yours, Super AI.